Hello everybody and welcome to the second episode of this series where I teach you how to build a redstone computer. Last time in the first episode I talked about what you're going to learn in this series. I talked about different modules, so if you haven't seen it yet, I highly recommend for checking that out because you will really learn what you will learn. So you can determine if this will be a good series for you to watch. But anyway, if you have seen it, before we start making the actual computer, we need to talk binary. So in this episode, I will first teach you what a bit is and a byte and binary. Then I will teach you how to count with bits, and then at last how to add with bits. So first, what is a bit and a byte and binary? Well, binary is actually a counting system, but instead of it being 10 base like the counting system we used from 0 to 9 with 10 digits, it only has 2. It's a 2 base, so it only has a digit can only be a 0 or a 1. That's binary. It's just a counting system. Now, a bit is just one digit or one line or one whatever you want to call it. It's just one digit that can either be a 0 or a 1, just like in our counting system that you use every day. Now, oh yeah, and one last thing, a byte. A byte it's quite easy. A byte is just 8 bits. That's it. A byte is just 8 bits. It's as simple as that. So this is 1 bit, and this is 1 byte. Because 1, 2, 3, 4, 5, 6, 7, 8. 1 byte. So if I'm talking about 4 bits, I mean if I'm talking about 1 byte, I mean 8 bits. So my computer is a 4-bit computer, so that means it can process 4 bits of data at once. Now, why do we use a 2-base counting system in computers, virtual computers or general computers in real life? Well, it's very easy to represent a 0 or 1. It's just if a line is off, that means it's 0. If it's on, then that means it's 1. It is possible to represent 10 different numbers, but it's quite hard, and you will get a lot of errors. So that is why we use just a 2 base. Next, how do you count with bits? Well, there's a problem here. You see, if you just interpret this as 4 different bits, you can really get a lot of numbers. You can get here 2 numbers, here 2 numbers, and so that's only 8 different numbers. But you can have different combinations if you use them together. So you use exponential growth in the same way you use in the 10 base system. Now, it works in the same way, because if you take the system you use every day, from 0 to 9, so with 1 digit you can represent 10 different numbers. But if you go to 2 digits, then you can already represent 100. That's not double the amount of 10, that's 10 times the amount. If you go to 3 digits, you can only represent 1,000 with only 3 digits. So that way it constantly goes bigger and bigger and bigger and bigger, exponential growth. It works the same way in a 2-base system. It's only it's not as fast. Don't get as big as fast, but you'll get there eventually. So with this one, you can still only represent 0 or 1, but here with 2, you can already represent 4. You don't really see the impact of that here, but you will see it when we get to the third one. So this is 0, 0, so 0, 0 means 0, this is 1, this is 2, and this is 3. So from 0, 0 to 3. Now, with 3 digits, you can already represent 8 different numbers. So, for example, this is 1, but you can already go to 5 with only 3 digits. With 4, you can already do 16, I mean, then 32, 64, 128, so the powers of 2. Now to calculate how much numbers you can get with a set amount of bits, you just take 2 and raise that to the power of the amount of bits you have, and then you'll get it. So with this one you have 4 different bits, so 2 to the power of 4 is 16, so you can have 16 different numbers. Now how to count with these? Well, just to go from 0 to 15, you start right, and first you set it all to 0, of course. So first, the most right bit you set to 1, so this is 1. Then you need to look at the most right bit again, and if that is a 1, you look to the bit left to it. Is that also a 1? You look to the bit left to it. Is that also a 1? You look to the bit left of it, and so on and so forth. Now if you encounter a 0, then you need to flick all the zeros to 1 that you have encountered, and the last 0 that you saw, that needs to be a 1. So in this case it's only 1, 1. So this is 0, this is 1. Now if you don't have any bit, if your most right bit is not a 1, then that will be your 1. Now here you have, that's 1, that's 1, that's a 0, so this one is a 0, these two, a 1, and these two need to be a 0. Now you have no bits right that are 1, so this is a 1. Now this is 1, this is 1 again. Now you have 3 bits in a row that are 1, so this is 1, and those are all zeros. So this is again a 1. Here it's full, here it's a 1 and a 0, so 0 and 1, back, and you will create a pattern. You will see that you create a pattern. So now this is 15. Now if you get a number, to know which number it is, you assign every bit to a number in the 10 base system. So you start at the most right one, and you give that to number 1, then 2, then 4, 8, 16, 32, 64. So again the power of 2, the powers of 2. Then you look at which numbers are all 1. So in this case the 1 is 1, 2 is 0, 4 is 1, and 8 is 1. Now all the numbers that are 1, so 4 and 1, you add them together and you have your number. So this is 5. Then if you, for example, do this, 1, so 1, 1 plus 2, so that's already 3, so 0, we can skip this one. Then last one, this is 1, 8, we already have 3, 3 plus 8 is 11, so this number is 11. If you just have a number in the middle of a row and you want to know which number that is, to calculate that you need to take 2 and raise that to the power of the which number it is counted from the right minus 1. So in this case, for example, that's the third one. So 3 minus 2 is 1. The S2, I'm sorry, math is hard. 2 to the power of 2 is 4. And so this number needs to be 4. So that's how you count with bits. At last, how do you add with bits? For that, I set up this lovely table. What do you need to call it? Raster, I don't know. Anyway, how do you add with bits? So this is your input. These are your 2 input lines. Don't worry about this line yet. And this is your output line. So let's start with a simple one. For example, this you need to add this with this. So this is 0 to 4, so this is 4, this is 1 to 4, so this is 4, and this is 1. So 4 plus 1, that should be 5. 5 is this, so we should get this. Now, how do you add? It's the same with the 10 base system. So here you have 0 plus 1, that's 1. So you flick this to a 1. 0 plus 0 is 0. 0 plus 1 is 1. 0 plus 0 is 0, and here you have nothing, so that's also a 0. And wouldn't you have it? We have 5. Now a little bit more complicated. If you have this, so this is 5 plus 1. So now we should get 6. 6 is this. If you have 1 plus 1, you have 2. What is 2? 2 is 0, 1. Now you only have one digit here. So what do? You go to the next row and you add 1 to that row. So and you leave that one alone. So this is 0, 1. You can see it like that. So this is 2. 0, 1, 2. Now here you have 1 plus 0 plus 0. So that's 1. Again, this is again 1. And this stays 0. So now we have 6. Even a little bit more complicated. If you have like this, and let's do that as well. Okay, so this is quite a big number now. Here you have 1 plus 4 plus 8 is 11. Wait, 13. I'm sorry. 1 plus 2 plus 8, that's 11. So 13 plus 11. Now 13 plus 11 is already above 15, so we'll need to use an extra bit. 30 plus 11 is 24, so we should get 24. So this is 16 in this case. So 1 plus 1 is again 2, this 1, 0. 1 plus 1 is again 2, so 1, 0. Now 1 plus 1, again 0, 1. Now we have 3 numbers, 3 times 1. So 1 plus 1 plus 1 is 3, like I said. Now, how do you represent 3? 1, 1. So this one, you flick to the 1. And if there was another row here, this one you would also flick to a 1. But in this case, this needs to be a 1. So now we have 24. That's 1, 2, 4, 8 plus 16 is 24. So that's how you add with bits. It's the same as in the 10 base. Now this is the basics for bits and bytes. You can also subtract, multiply, all the shebang. Next week we'll cover logic gates. What they are, how do you make them, how do you use them, all the jazz. Now if you like the video, recommend subscribing and liking. It would really make my day. Thanks for watching and have a good day. Bye.